Hello everyone, in today's lesson we're going to learn what the complex number is, how to classify it, and how to simplify complex numbers. Let's review some properties of real numbers, the numbers we use and we well know. So we have some subcategories and we're going to begin with the smallest set. It's called whole numbers, and the whole numbers are numbers that begin with 0. So they're going to be 0, 1, 2, and so on. So there are the whole numbers, only positive including 0. Then we have a bigger set. Those numbers are called integers, and the integers include now negative numbers. So they're going to be negative whole numbers. So they could be any number, the numbers you find on the number line, but not including fractions. And of course positives as well. Rational numbers, as you can probably get an idea from the first part of the word rational, it's a ratio. So these numbers actually can be expressed as fractions, as a ratio of two integers. So those numbers are like 0.5 because it could be expressed as 1/2. So it's a ratio of 1 to 2. There could be negatives. There also could be fractions, for example, as -2/3. When you turn it into decimal, that decimal is going to repeat. So any decimal that repeats or terminates is classified under rational numbers. And then we have a separate position of irrational numbers. So irrational number is a number that is not rational. So a number that cannot be converted back into a fraction. And the famous irrational numbers are square roots of not perfect squares, like square root of 2, square root of 11. For example, pi is one of them because that's a decimal that doesn't really end. Number e, and so on. So these numbers are irrational. All of them combined together consist, and this whole big set is called real numbers. So all of these numbers are called real numbers. Those are the numbers we well know. And then we have even a bigger set than real numbers. That set is called complex numbers. And those complex numbers are not there to make our life complicated. They're just different category. And complex numbers are actually, we have two categories. We can have pure imaginary. And these numbers are called, actually we express it with I is the imaginary number. So I is actually a number, not a letter. We can have 3i, we can have -2i, and so on. And then we have a complex numbers that are actually in the form of a plus bi. So they have what's called real number, so we call it real part, and they have imaginary part. Trying to write it. So imaginary part. And examples of complex numbers are, for example, 1 plus 2i, that's just one number, -3 plus i, and so on. So now take a moment and in part A, define imaginary unit I. So this is just a number, and I would like you to write your own definition in your own words. And in part B, describe the standard form of a complex number, which I just did. So just give an example of your own. So before moving on to simplifying imaginary numbers, let's review some basic exponent rules. So when we raise a negative number to an exponent to a power of 2, it means we multiply -2 by itself 2 times. So that would give us +4. The next rule is when we have the same base. In our example, the base is x, and we have x to the second power times x to the third power, the rule is keep the base, add exponents. So the answer is x to the fifth. If we have power to a power, so we have x to the third and raised to the second power, the rule is keep the base, multiply the power. So that's going to be x to the sixth. So now let's see how imaginary number pattern actually works. So imaginary number I is defined to be the square root of a negative 1. Then I to the second power, we can take square root of negative 1 and square it. If we take square root of negative 1 times square root of negative 1, we'll get negative 1. So I squared equals negative 1. So it has an actual value. I to the third, I can break down and write it I to the second times I to the first power. And by looking at my previous answer, I know that I to the second is negative 1 and I to the first is just I, so the answer is negative I. So I to the third is negative I. I to the fourth, I can rewrite as I squared times I squared. And I know what the I squared is. It's negative 1 times negative 1 is equal to positive 1. So I to the fourth is positive 1. And imaginary numbers actually are cyclic, which means that every fourth power they're going to repeat and they're going to have the same value. So right now we have all of the answers that we actually need. So I to the fifth will go back to I to the first power, and you can always figure out, you don't have to remember it. So I to the fifth I can rewrite as I to the fourth times I to the first. I know I to the fourth is 1 and I to the first is I, so the answer is I. I to the sixth I can rewrite as I to the fourth times I squared, which means I have 1 and I to the squared is negative 1. So the answer is going to be negative 1. It's the same answer as I to the second, if you noticed. I to the seventh, I can write as I to the fourth times I to the third. And I know I to the fourth is 1. I to the third, I know is negative I. So the answer is negative I. I to the eighth is I to the fourth times I to the fourth, which means 1 times 1 equals 1. So I got another cycle. And then I can keep going on forever. So let's do 2 more. I to the ninth I can write as I to the fourth times I to the fifth. So I have 1, and then let's go back and find out what I to the fifth is, and I know it's just I, so the answer is I. Let me erase that. I to the 10th, I can write I to the fourth times I to the fourth, which is I to the 8th, times I squared. So when I add exponents, I get I to the 10th. So I have 1 times negative 1, which equals to negative 1, and so on. And we can continue and go in cycles. So when simplifying imaginary numbers, we want to rewrite it in the lowest terms possible. So we're going to always rewrite the power of imaginary number as a multiple of 4. Plus the number, and then use I to the fourth is equal to 1, which is an easy computation and simplifying process. So for example, if I have I to the 87th power, I'm going to take 87 and divide by 4, right here. And I know that 4 goes into 87 21 times, and I have a remainder 3. So now I can rewrite I to 87 as I to the fourth to 21st times I to the remainder. And I know that I to the 4th is just 1, so I have 1 to 21st power times I to the 3rd power. And 1 to the 21st power is just 1. And you can go back, look up on your paper, and we know that I to the 3rd is going to be negative 1, I. So the answer is negative I. So try example A and B on your own. Pause the video at this time. When you're ready, unpause it and check your answers. So I'm going to take 22 and divide by 4. And I know that 4 goes into 22 5 times. And I'm going to have 2 left over. So I can rewrite I to the 22nd power as I to the 4th to the 5th, which is I to the 20th, times I squared. So I get 1 to the power of 5 times I squared. 1 to any power is always 1, so we're going to forget about it. We're not going to write it. And I squared, I know, is just negative 1. And I'm done. So now 61 divide by 4. So 4 goes into 61 15 times. And then I'm going to have, because 4 times 15 is 60, so the remainder is 1. So now I'm going to rewrite I to the 61st power as I to the 4th to the 15th. That will give you I to the 60 times I to the 1st. So I have 1 times I, which equals to I. So what's left for you to do is to explain what method can be used to evaluate the I to the nth power and explain the steps. Nth power means any power. So just pick a power as your example and just explain the steps, how to simplify based on the examples we just did.